Today we will see story of statistician, who nails down Murphy's Law. Anything that can go wrong, will go wrong, that is what Murphy's Law says. Story starts with battleground of Second World War. It was a scary time of the Second World War, and the Germans were determined to take out as many US planes as possible. They had many frightening demons in their control to accomplish this. One of the main methods they used was anti-aircraft artillery, also known as flak. These giant guns on the ground fired at planes flying overhead, and they were particularly effective against bombers and could take out multiple planes at once. Another trick the Germans employed was using fighter planes like the Messerschmitt Bf 109 and the Focke-Wulf Fw 190. These planes were explicitly designed for air-to-air combat and could engage US planes in air fights. The Germans also had night fighters, like the Messerschmitt Bf 110, which could take out US planes flying at night with the help of radar and infrared technology. The Germans also relied on camouflage and deception tactics, which were very effective in fooling the US pilots and their planes. These tactics could be considered as a scary demon. They would camouflage their anti-aircraft artillery and fighter plane bases, making them difficult to spot from the air. They also used decoys and dummy targets to distract and mislead US pilots. In addition to these fire and brimstone, the Germans also had innovative technology like the Wasserfall missile, the first ground-to-air missile, and the first anti-aircraft guided missile to be used in combat. Introducing this new technology was a significant threat to US planes. The US Army Air Corps desperately tried to protect their aircraft from this inferno. What clue they had? Some survived aeroplanes come from that doom. But we all know people only see what they are prepared to see. The US Army Air Corps analyzed planes that survived airplanes with enormous battle wounds. The state of those airplanes was devastated. Most of its body had bullet marks, and one had praised how lucky that plane was. After that analysis, experts came to a conclusion to reinforce most damaged parts of the airplane in different designs. It was completely logical if one considered available data they had. But what if, after strengthening, there is a plane crash? The design expert had yet to have an answer. They have relied on luck or Murphy's Law. Anything that can go wrong, will go wrong. But they lacked true perception. Murphy's Law. One genius mind was present in that expert, who went against popular opinion with a more logical argument. The popular approach failed to consider that the planes that didn't make it back, the casualties, if you will, were probably hit in the same crucial areas where the returning aircraft were not hit. Statistician Abraham Wald saw this as a significant problem and came up with a solution. He suggested protecting the areas where the returning planes didn't have any bullet holes, since that's probably where the aircraft that didn't return was hit. It was like a detective trying to solve a crime but only looking at the surviving victims and not the casualties. Abraham Wald pointed out that the key to solving the problem was to look at the whole picture and not just the surviving part. The Army Air Corps took Wald's advice and started protecting the areas where the returning planes didn't have any bullet holes, and the result was that more planes could survive and return home safely. This example illustrates how survivorship bias can lead to inaccurate conclusions and the importance of considering the entire population, including the failures, when making decisions or drawing conclusions. Survivorship bias is also known as selection bias. Let's see how selection bias and Murphy's Law correlate each other. Murphy's Law is often applied to situations where the outcome is uncertain and implies that unforeseen and unfortunate events are bound to happen. Selection bias, on the other hand, refers to the tendency for individuals or groups to be disproportionately represented in a sample, resulting in inaccurate conclusions about the population as a whole. Selection bias can occur in various forms, such as self-selection bias, where individuals choose to participate in a study, or sampling bias, where a non-random sample is used. When Murphy's Law and selection bias are combined, it can lead to a situation where adverse outcomes are disproportionately represented in the data. For example, a study on a new medical treatment may only include patients with a particularly severe form of a disease, leading to skewed results that make the medicine appear less effective than it actually is. To mitigate selection bias, researchers must ensure that their study samples represent the population they aim to study. They should use methods such as random sampling to minimize the chances of bias. Additionally, it is essential to be aware of Murphy's Law and the potential for unforeseen events that can impact the results of a study. In summary, Murphy's Law is an adage that states that things will go wrong, and selection bias is a tendency for specific individuals or groups to be disproportionately represented in a sample. Murphy's Law and selection bias can lead to skewed and inaccurate conclusions about a population. It is crucial for researchers to be aware of these potential issues and to take steps to mitigate their effects.